Good day, grade 12 learners. My name is Nikiwe Zulu. I am going to be presenting mathematical literacy, and today's topic is going to be based on maps, plans, and other representations of the physical world. Now, learners, this is a very large section in mathematical literacy because in your exam, in both paper 1 and paper 2, it carries plus or minus 15% of the exam. That means that for your paper 1, which is out of 150, plus or minus 23 marks falls under this section of maps and plans. And then also in paper 2, which is also out of 150, plus or minus 23 marks falls under the section of maps, plans, and other representations. As this is a very large section, for today's lesson, our main focus is going to be on scale. I'm very excited to be doing this topic. It is a very exciting and easy section, and I hope all of you are going to enjoy it. Now, under this section of maps, plans, and other representation, our main focus is going to be on scale, the types of scale, and the application of scale. Our lesson objectives. By the end of today's lesson, we should be able to work with different types of scales. We should be able to explain the meaning of the given scale. And then I will go deeper into that as we work with the different types of scales. We should be able to use a given scale to determine the actual measurements. We should be able to use a given scale in conjunction with the measurement on the map to determine the length and the dimensions. And lastly, we should be able to determine the scale of the map or the plan. Now, mathematical literacy is a subject that has a lot of literature in it. So before we can actually apply whatever content that we know into solving our problems, we must first be familiar with the common terms that are used in the subject. So I'd like us to quickly break down the common terminology that we are going to come across into this section before we can do our calculations. So the first word is a scale. What is the meaning of scale? Scale is used to indicate how much an object has either been reduced or enlarged from its actual size. When I talk about an object being enlarged or reduced, let's take for an example. I have my cell phone here, and then on my cell phone, I have my image. This is a picture of me, and it's a full-length picture. You can see myself, my entire body is here. But we can all see that my actual size, I am not this small, I am this big. It means here the concept of scale has been used in such a way that my actual image has been reduced to be able to fit into this cell phone. That is what is meant, that a scale is when an object has been reduced than its normal size. And it's not always going to be the case that objects are reduced. Sometimes objects can be enlarged. Let's take, for an example, a billboard that you see on your way to school. And then let's say maybe on the billboard they are advertising a cell phone. The cell phone on the billboard is not going to be this small because the billboard is aimed for people, for everyone that is coming from a distance to be able to see whatever it is that is advertised there. So the cell phone as small as this will have to be enlarged on the billboard than its original size. Again, that is the concept of scale, where an object has been enlarged. Another practical example, for those of you that have seen the Madiba statue, the Madiba statue is very big, it's a giant. Does that mean that the actual size of Nelson Mandela was that big? No, it means his actual size, his actual length was actually enlarged by a certain scale factor to make it look that big. That is, again, where the concept of scale comes in, where an object has been enlarged. I hope we all understand what is meant by the word scale. It is when an object has either been reduced or enlarged from its actual size. The other word that we are going to come across is a number scale. A number scale is a type of scale which is also known as a ratio scale. We say it's a ratio scale because the way that it is written as a ratio. An example that I've used here is 1:500. Now, the most common question that you would get for this kind of a scale, the examiner would normally ask you to explain the meaning of this scale. What does it mean? it means that 1 unit on the map represents 500 units in reality. You need to be very careful that the units must always be the same. If you don't want to use the word unit, maybe you can use your centimeters. And when you explain, you would say 1 centimeter on the map represents 5 centimeters in reality. You can use kilometers. You will say 1 kilometer on the map represents 500 kilometers in reality. What you need to know that the way that a scale is written like this, it is always the map distance. Oh, I'm sorry about that. Let me write this side. It is always the map distance is to the actual distance. So it's always your map distance is to your actual distance. So if using this example to say 1 is to 500, that's why I'm saying that it means 1 unit on the map represents 500 units in reality. Or you can say 1 meter on the map represents 500 meters in reality. The main thing is that your units must always be the same. And then it is not always the case that your distance on the map is smaller than your actual distance. Sometimes you will get a scale like this, 250 is to 1. And how do we explain this? You don't panic and say, no, the 250 is the actual. No. When your scale is like this, it means now your object has been enlarged from its original size. So how would you explain this scale again? This is still your map distance. You will say 250 units on the map represents 1 unit in reality. This is a case where an object has been enlarged. I know we are most of us are familiar with the map distance being smaller than the actual distance. So take note, it will not always be the case. This is the case when an object has been reduced, but if it's like this, when the map distance is bigger than the actual distance, it means now an object has been enlarged. And then also take note that like I said, that your units must always be the same, and then your scale, again, it must always be in its simplest form. By simplest form, I mean that it is written in such a way that it cannot be simplified any further. Like your 1 is to 500. It ends there. We cannot simplify this any further. 250 is to 1. This is the simplest form. You can't continue simplifying it. And then we have a bar scale. A bar scale is another type of a scale. Remember I said we have different types of scales. We actually have 2 types of scales. The first one that we just discussed, which is a number scale, and the second one is a bar scale. A bar scale is also known as a graphical scale, and it is presented as a picture. It means that if you placed a ruler next to this scale, you could determine how many centimeters represent a specified number of kilometers. Now, to explain this bar scale further, we'll have to do it practical. Now, in the section where we do bar scale, that is where I will show you how to explain a bar scale thoroughly. And the use of a ruler for this section is very, very important. And then we have the distance as the crow flies. This, you'll normally come across this in the exams, when the examiner will say, calculate the actual distance from point A to point B as the crow flies. What does the distance as the crow flies mean? It means a straight line distance from point A to point B. So if you have point A and then you have point B, when you measure your distance with a ruler, a straight line distance, this is what is meant by the distance as the crow flies. Even if maybe there was no route here, and then you had to pass point C first for you to get to point B. But when they say the distance as the crow flies, it is just a straight line distance. So when they say calculate the distance as the crow flies, you know that you need your ruler and measure your distance as a straight line from one point to the other. That is what is meant by the distance as the crow flies. And then we have the actual distance. The actual distance is the real distance between any 2 points. And most of the time, that distance would be calculated in kilometers. That is when we are calculating the distance from one place to the other. But then if you are talking about smaller objects, like maybe you are calculating the actual distance, the actual length of a book, then you cannot use kilometers there, but you'd rather use centimeters or millimeters. And again, depending on the instruction from the question. And then lastly, we have the map distance. The map distance, that is the distance between any 2 points on a piece of paper, where you use your ruler to measure. Then that type of a distance, we call it a map distance. I hope we all understand these concepts, because we are going to come across them as we are tackling our questions on the concept of scale. And then now, under scale, the first part is a number scale. Like I've said, that a number scale is also called a ratio scale because it is written as a ratio. In the exam, especially in the exam, when you are given maybe a map and then there's a scale, the examiner can ask you to identify the type of scale that is used. So if you say it's a number scale and the other learner says it's a ratio scale, both of you are correct, because if you don't want to say a number scale, you can say it is a ratio scale. Both the two learners would get full marks. And then it is always expressed as a ratio. An example is 1:5,000. And remember, as it is written, the first unit, it is always your map distance, and then your second unit is always your actual distance. So 1:5,000. If you were to explain this, you will say 1 unit on the map represents 5,000 units on the ground, or 5,000 units in reality. Learners, please take note that you will always be asked to explain the meaning of the given scale. So make sure that you master this. It is a very easy concept to master, so this one is your 2 marks for free. Especially in paper 1, if they've given you a map, or if you see a question and then there's a number scale, you must know immediately that you are definitely going to be asked to explain the meaning of that scale. And when you explain it nicely that 1 unit on the map represents 5,000 units in reality. The common mistake that learners make, they would know how to explain the scale, but they don't explain it thoroughly. A learner would say 1 unit represents 5,000 units. 1 unit where? 5,000 units where? So you need to be specific that it is 1 unit on the map represents 5,000 units in reality. And another mistake again, remember I said the units must always be the same. So if you don't want to use the word unit, you can use centimeters, you can use millimeters, you can use meters. It is up to you. But you must make sure that if you've decided to say 1 centimeter, then the 5,000 must also be in centimeters. If you are going to say 1 meter, then the 5,000 must also be in meters. So then you will say 1 meter on the map represents 5,000 meters in reality. The common error that learners make, they will say 1 centimeter on the map represents 5,000 kilometers in reality, and that is absolutely not correct, especially when it comes to a ratio scale. The units must always be the same. Please remember that. And then the scale should always be in its simplest form. Like I said, if you are given your scale, maybe you get a question that says, determine the scale that was used for this diagram. When you do your calculations, the examiner will not tell you that your scale must be in its simplest form. As a learner in grade 12, mathematical literacy learner, you should know that your scale must always be in its simplest form. Let's say you are doing your calculations, and then your scale, you got a scale to be 2:450. This 2:450 is not in its simplest form, because this side you still have 2, and then you have 450. It means when you say it's in its simplest form, one of the ratios has to be 1, because then from 1, we cannot simplify it any further. So now let's simplify this scale. From 2, we have 2:450. So we need to get rid of this 2 so that we are left with 1:something. So how do we get rid of the 2? We have to divide by 2, and what we do this side, we must also do on the other side. And then 2 and 2 will cancel. You have 1 is 2. 450 divided by 2 will give us 225. Now your scale is 1 is to 225. And then your scale now, it is in such a way that it cannot be simplified any further. This is what we mean that your scale should always be in its simplest form. And then as far as the decimals are concerned, when you are calculating your scale, sometimes you'll get an answer as a decimal. And it will depend on the instruction. The examiner can say, determine the scale to the nearest 10, or determine the scale to the nearest whole number. Then you know that your final answer must not be a decimal, but it has to be a whole number. But if there is no instruction, the question was just saying determine the scale, it means you will do your calculations. If it is in a decimal form, what does the instruction say in the exam? They say that we must always round off to 2 decimal places unless stated otherwise, or it also depends on the context that you are working with. Because remember, if you are calculating the number of people, you cannot have a decimal number of people. If you want to know the number of tiles that you must buy, you cannot have a decimal number of tiles. So you will also be guided by your context. And then sorry about that. We have the advantages of working with a number scale. One of the advantages is that we only have to measure one distance. So if you are given a number scale and you are required to calculate the actual distance, it means you are going to need your ruler to measure the map distance and use that map distance that you've measured with your scale factor to determine your actual distance. So you only have to measure once. And then secondly, if the distance is given, sometimes the examiner can be nice and give you the map distance to say if the map distance is 3 centimeters, calculate the actual distance using the scale. So yours is just to do the short calculation and then you get your full marks. And then lastly, calculations are fairly simple. You will see the calculations on a number scale are simple and straightforward. So there are no hassles when it comes to a number scale. But I hope you learners, you realize the importance of a ruler when it comes to this section of scale, that a ruler is as important as your calculator. That means that you can no longer go into an exam room without a ruler, and a proper ruler with all the numbers visible on it. And then, as much as we have the advantages, we also have the disadvantages of working with a number scale. One of the disadvantages is that when the plan or a map or even an image is resized, by resized I mean if it is made smaller than the original image or if it is made bigger than the original image, then our ratio scale becomes inaccurate. It means we can no longer work with our number scale because now it is no longer accurate. We are no longer working with the original image. That is one of the disadvantages of working with a number scale. And now moving on to a bar scale. A bar scale is also called a graphic scale, or it is called a linear scale. And again, in the exams, one of the questions that can be posed, the examiner can ask you to identify the type of scale that is used on that diagram. So you will know that if you see the bars like this is your bar scale, or you can say it's your graphic scale, or you can say it is your linear scale. Either one of the three is correct. You will get your full marks for that answer. A bar scale is represented in segments. By segments, we mean these blocks. That is how we know that this is our bar scale. And then each piece of the segment represents the given distance. Let's look at this example, this bar scale that we have. We can see that from the beginning here, it's 0 kilometers. Right up until in the middle here, it is 12 kilometers. And then from here, right till the end, it is 24 kilometers. So this bar scale in full length, as full as it is, it represents what? 24 kilometers. So now the examiner, especially in paper 2, they can ask you to explain the meaning of this bar scale. Now, how do we explain the meaning of this bar scale? With a bar scale is different from a number scale. Remember, with a number scale, I said that the units must always be the same. But then with a bar scale, your units do not have to be the same, because this is a small part, and it already represents what? 24 kilometers. So then how would you explain this bar scale? This is how you're going to explain it. You are going to take your ruler. I actually prefer working with the millimeters. You can use your centimeters, it's fine, but I think it's advisable to work with the millimeters, because the millimeters has, even if you are getting the decimals, it has those small numbers that you can see that, okay, it is 10, 11, 12, 13, 14. Whereas with the centimeters, the gaps in between, if maybe you are getting 7,2, most of the learners would struggle. They'll just run away and say it's a 7. So to be on the safe side, let's rather work with the millimeters, because it is easier. It has all the values that we need on a ruler. So when you explain a bar scale, your major resource is your ruler. You're going to take your ruler, the millimeter side, and then learners, make sure that when you measure from your point 0. Most of the learners, they make a mistake of measuring from where the ruler starts. That is incorrect. Please, you measure from 0, and then I'm measuring my bar scale. I'm getting 220, 225. So when I measure on a piece of paper, I got 225 what? Millimeters. It is equivalent to what? To 24 kilometers. So now, how do I explain this scale? I'm going to say the 225 millimeters, that is measured on the paper, or you can say on the map. 225 millimeters on the map represents what? 24 kilometers. In reality. I hope you can see this. I reduced it by mistake. Let me try and expand it just a little bit. There we go. So your 225 millimeters that you measured with a ruler, it's 225 millimeters on the map, represents 24 kilometers in reality. That is how you explain the meaning of a bar scale. You don't have to worry about the units that are not the same. I hope this makes sense. And now the advantages of working with a bar scale: when the map is resized, it does not affect our bar scale, because our bar scale will also be resized by the same factor. So if the map is enlarged, our bar scale will also be enlarged. And if the map is reduced, the bar scale will also be reduced by the same factor. So whether you are resizing the map or not, the bar scale will not be affected. That is one of the advantages. And then secondly, the calculations when working with a bar scale, you will see as we do our calculations, they are also very quick and easy to use, straightforward. And then as much as we have the advantages, we also have the disadvantages of working with a bar scale. And one of the disadvantages is that one has to measure the length of one segment. Like you saw in the previous example, you first have to measure the bar scale and then create your own scale. And then after that, you'll have to measure the map distance for you to be able to calculate your actual distance. So there's a lot of measuring that happens before you can actually come and do your calculations when it comes to a bar scale. And then secondly, certain instruments are used to measure a bar scale, like a ruler. So if you don't have a ruler in the exam room, you are really going to struggle when it comes to answering this section of a bar scale. So a ruler, a proper ruler with the visible numbers, is very, very important when you go into your exam room. And then, before we can start with our calculations, let us quickly remind each other of the conversions, especially the length conversions. Remember in term 1, the first week when you reopened the school, you did conversions. You did conversions of length, mass, and volume. But for this section of scales and working with maps, we need your knowledge of the length conversions. So this is very, very important. And grade 12 learners, you are expected to know these conversions by head. They will not be given to you. For the metric conversions, you must know them by heart. But if it's the imperial conversions, then those ones you don't have to know, like your feet, your pounds, you don't have to know them. They will be given to you. But for our metric, you need to know them by heart. So I normally use the King Henry method. What do we say again? King Henry died miserable death called measles. And then we know that in between all of these, there's a 10 here, there's a 10, there's a 10, there's a 10, there's a 10, and there's a 10. Meaning that if you are moving from millimeter to centimeter, the conversion factor is what? Is a 10. If you are moving from millimeter to meter, the conversion factor is 10 by 10 by 10, which is a 1,000. Now, a kilometer is far bigger than a millimeter. So it means as you are going this side, the units are getting bigger. So if you are moving this side, the units are getting smaller. So what does that mean? It means now if you are moving from a larger unit to a smaller unit, we are moving from a larger unit to a smaller unit, we are going to multiply. But if you are converting from a smaller unit to a larger unit, then you are going to do what? You are going to divide. And learners, for maths literacy, the most common units that we use for our conversions, it is your kilometers, it is your meters, it is your centimeters, and then it is your millimeters. This does not mean that the examiner will not ask you about the densimeters and the hectometers. They can ask you about those ones, but the most common one, the ones that we work with on a regular basis, are these four. These are the ones that you need to master. Let us look at the conversion factor between them. Between a millimeter and a centimeter, there's only what? There's only a 10. And then between a centimeter and a millimeter, how many tens are there? It's 1 10 and a 2 10. So it is 10 by 10. 10 by 10 means 10 multiplied by 10, which is equals to 100. And then from meters to kilometers, we have 10 by 10 by 10, which is 10 multiplied by 10 multiplied by 10. It is going to give us how much? 1,000. Take note, this is not 10 multiplied by 3. It is 10 multiplied by 10 multiplied by 10 to give us a factor of 1,000. And remember, when you are converting from kilometers to meters, you are moving from a larger unit to a smaller unit, you are going to multiply. When you move from a smaller unit to a bigger unit, you are going to divide. Let me write it again. If you are going the opposite direction, then you are going to divide. It means if I was calculating from kilometers to centimeters, the conversion factor would be what? 100,000. If I'm converting from millimeters to meters, it would be 10 and 100 is going to be what? 1,000. I hope this makes sense. So this is just a reminder. I am not teaching this. Remember, we've already been taught this section. This is just a reminder so that as we do our calculations, it is easier to refer back and use our conversion table to assist us in doing our conversions as we are calculating. And then using a number scale. This is the first example. Explain the meaning of the following ratio scales. Learners, you are always going to get a question like this. When you have a question, especially paper 1, the question on maps and plans, if they've given you a scale, you are definitely going to be asked to explain the meaning of the scale. So let's look at A. How do you explain? What is the meaning of the scale? Is 1 is to 10,000. 1 is to 10,000. Remember I said this is the map distance and this is the actual distance, always. It doesn't change. So this means that 1 unit on the map represents 10,000 units in reality. That is your answer, and then you get your full 2 marks. That is if you are asked this question in the exam. Normally, it's for 2 marks. And then B, you must also explain the meaning of this scale, which is 500:1. Remember when I started, I said your number scale is not always going to be in such a way that the map distance is smaller than the actual distance, because sometimes objects are enlarged. And that is why now you get that the distance on the paper is actually bigger than the actual distance. So how do you explain this one now? It is 500:1. It doesn't change. The order does not change. This is still the map distance. This is still the actual distance. So when you explain it, you will say 500 units. 500 units. Sorry. I'm sorry about that. 500 units on the map represents 5,000 units on the map represents 1 unit in reality. And then again, this is where you get your 2 marks by just explaining the meaning of the given scale. That is example number 1. And then the second example, the image of Carl is shown below. His actual height is 1.3 meters. So we are given the actual height. Remember I said when you write a scale, it is always the map distance is to the actual distance. So in this case, we are given the actual distance to say that the actual distance is 1.3 meters. So I'm going to write it under actual. Use the actual height, which is 1.3 meters, to help you determine the scale that is used to resize the image. Guys, we know like the actual Carl would not be this small. So it means the original image of Carl has been reduced to be able to fit on this photograph. So we are going to use the actual height, which is 1.3, that to help us determine the scale that was used to resize him. So your first step, you are going to take the ruler and determine what is his height on the paper or what is his height on the map. So I'm going to take my ruler and use my millimeter side to measure his length. And then I got between 160 and 170, 165 millimeters. So the measured distance is 165 millimeters. Guys, look at this. This is a ratio scale. This is a number scale. And there are 2 principles of a number scale. One is that units must always be the same. And then secondly, the scale must always be in its simplest form. So now we have our scale there. Our units are not the same, and then our scale is not in its simplest form. So we have 2 options. We can either convert our millimeters to meters, or we can convert our meters to millimeters to make the units to be the same. What I normally advise my learners is to always convert a larger unit into a smaller unit, because when you convert from a larger unit to a smaller unit, we multiply. And when we multiply, that helps us to get rid of the decimals, because in Mathslit, we don't like working with decimals. We don't want complex stuff. We just want to flow. So now we are going to go back to our King Henry. Let me first write here. You have 165 millimeters is to the 1.3 meters. How do we convert from meters to millimeters? Let's quickly go and check our King Henry. We are converting from where? From meters to where? To millimeters. So what is the conversion factor between a meter and a millimeter? It is how many zeros? 1, 2, 3, which means it is 8,000. And because we are moving from a larger unit to a smaller unit, therefore we are going to multiply, and we multiply by 8,000. So I'm going to take my 1.3 meters and then times it by 8,000. So we're going to say here we are left with 165 is to, guys, in Mathslit, we rely on calculators. So you will never ever be penalized for using your calculators. You use it, even if you feel that the answer is obvious, please double check it on your calculator. So it is 1.3 multiplied by 1,000, which is equals to 1,300. It is 1,300. Now, you will see that my units are now the same. That is why I'm not indicating any units. So the first thing, I've made my units the same, and I'm happy. And then secondly, is my scale in its simplest form? No, I still have 165. I have 1,300 on the other side. So now I need my scale to be in such a way that it cannot be simplified any further. So what am I going to do? I want to be left with 1:something. I'm going to divide this side by 165. And then I'm going to divide this side as well by 165. And then 165 and 165 will cancel. I'm sorry, let me just continue here so that they're all in the same slide. So 165, 165, you are left with what? 1:2. And then you have 1,300, and then you divide it by what? By 165, which is equals to 7,878. 7,878. And then we can say it is 1:7,888. Remember, guys, there was no instruction here that our scale must be to the nearest whole number or to the nearest 10 or to the nearest 100. So when you get a scale as a decimal, you do not panic. It is fine, especially if there was no instruction. We know if there is no instruction to tell us we need to round off to how many decimal places, we round it off to 2 decimal places, unless, again, otherwise, the context does not allow for any decimal values. So the scale that was used to resize this image is 1:7,88. And now, example number 3. This one is an example on a bus scale. And the nicest thing about it, we are not going to use our ruler because there's already a ruler that is in place for us. So we have our bus scale. Look at our bus scale. It starts at 0 meters. And then halfway, it is at 500 meters. And then after 500 meters, it is at 1 kilometers. Now, if you go back to your conversions, you will know that 1 kilometer is equivalent to 1,000 meters. So if another child says, no, ma'am, why don't we say this is 1,000 meters? It is still okay, because 1,000 meters and 1 kilometer, they are equal. And then the ruler that is used, our ruler, here at the beginning, it says 0 millimeters. And then from 0 millimeters, it says 1. This is not 1 millimeter. It's 0 millimeters here, then this is 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this actually means that this is 10 millimeters, but it's written 1. The 1 means that it is 1 centimeters. You can even use your ruler, your practical ruler, and then you will check with your ruler that 1 centimeter is equivalent to 10 millimeters. That is why here, where it's 1 centimeter, I'm saying that it is also 10 millimeters. So if it's 10 millimeters, 12, 13, 14, 15 millimeters, up to 20 millimeters. So where it's 20 millimeters, it's actually 2 centimeters on your ruler. I hope you understand the usage of this ruler and this scale. Now, the first question A, explain the meaning of the scale. How do we explain the meaning of the scale? There are different ways of explaining the scale. It is really up to an individual learner. This is a type of question where we can have about 4 different answers that are still correct. So the first part, I can look at the scale, a full scale, and then it is 4 here. And then we all agree that this is 4 centimeters. So when I explain the meaning of this scale, I'm going to say 4 centimeters on the map. That is measured with a ruler, right? 4 centimeters on the map represents 1 kilometer in reality. And then you still get your 2 marks. Remember, because we are working with a bus scale, the units don't have to be the same. Or someone else can say, no, ma'am, I want to say 2 centimeters on the map represents 500 meters in reality. That is also still correct. So you can say 2 centimeters on the map represents what? 500 meters in reality. You will still get your 2 marks. And then someone else will say, no, ma'am, I don't want to work with centimeters. I want to work with millimeters. So the other child can say 20 millimeters. Remember, it is 20 millimeters here. If you count these small lines, when you get here, it is 20. 20 millimeters on the map represents 500 meters in reality. The other one can say 40 millimeters on the map represents 1 kilometer in reality. So any of those explanations will get you your full 2 marks when you have to explain the meaning of this given bar scale. And then B, convert the bar scale into a number scale. Let's convert our bar scale into a number scale. Again, with this one, there are also different options. But even though there are different options, our answers at the end must still be the same. So I'm going to start with the middle part here. To say that 2 centimeters is equivalent to what? To 500 meters. So 2 centimeters is equivalent to 500 meters. We need to convert this to a number scale. Remember the 2 properties of a number scale? 1, the units must be the same. 2, it must be in its simplest form. So our first problem there, as we can all see, is that our units are not the same. And we need to make our units to be the same. We have a smaller unit, which is centimeters, and we have a larger unit, which is meters. So like I said in the previous example, that I always prefer to convert a larger unit to a smaller unit, because in that way, I'm going to multiply, and when I multiply, I know that my chances of working with decimals are very limited. So remember again, I'm taking you back to your King Henry. When you convert from meters to centimeters, what do we do? Let us quickly recap and help one another. Yes, sorry. We are converting from centimeters to meters. So we are moving from this unit to this unit. And the conversion factor there is how much? It is 100. I'm sorry. We are converting from meters to centimeters. So it means we are going to multiply. And we multiply by how much? By 100. So then we are going to take, okay, our 2 centimeters. And then we take our 500 meters. Remember, we are converting it, ne? And then we said we are multiplying by how much? By 100. So here we will have your 2. I'm not going to write the unit because now my units are the same. So you have 2. 500 multiplied by 100. Remember, again, you are allowed to rely on your calculator. You are not going to be penalized for using your calculator. So it is 500 multiplied by 100, which is equals to 50,000. It is now 50,000 what? Centimeters. 50,000 centimeters. The units are the same. We are happy. If you want, we can write your units, that it is centimeter here, it is centimeter then. So your units are the same, but now, is it in its simplest form? No. We still have to simplify this. We have 2 this side, we have 50,000 on that other side. Remember, we want to be left with 1 is to something. It means that if it's at 1 is to something, we cannot simplify it any further. So I'm going to take the 2. What must we do to get 1 here? It means we need to divide by 2. We can say 2 centimeters. This side, you also divide by 2 centimeters. Why the centimeter? So this centimeter and that centimeter can cancel. 2 and 2, they cancel. You are left with 1 is 2. 50,000 divided by 2, your best friend, your calculator. You say 50,000 divided by 2. What is the answer? 25,000. 25,000. Remember the centimeter and the centimeter, they have cancelled. So your scale in its simplest form, it is 1:25,000. That is, if you've used 2 centimeters, is equivalent to 500 meters. Let us see if we use 4 centimeters and 1 kilometer. Will our answers be the same? Let us check. If I'm going to use 4 centimeter, to say 4 centimeter is equivalent to 1 kilometer. The basic principles, first of all, our units must be the same because we want to convert this to a number scale. If it was a bar scale, we're working with a bar scale, we would be fine, we would be happy. But now the instructions said that we must convert that into a number scale. So a number scale, units must be the same. It has to be in its simplest form. We have centimeters, we have kilometers. So the biggest unit there is your kilometer. Remember my advice, I always say that it is better to convert your larger unit into a smaller unit so as to avoid working with large units. Now, let's see our 4 centimeter. When you convert our kilometer to centimeters, what is the conversion factor between a centimeter and kilometer? Let us go back again to our conversion table. Yes, so between kilometers and centimeters, how many zeros are there? It's 1, 2, 3, 4, 5. It is actually 100,000. So the conversion factor between centimeters and kilometers is 100,000. And now we are moving from kilometer to centimeters. Do we multiply or divide? Yes, we are going to multiply because we are converting a larger unit to a smaller unit. So we are going to take our 4 kilo, you write your 4 centimeter is to our 1 kilometer. Remember, we are converting it to centimeters, and we said we are going to multiply it by how much? By 100,000. It's 100,000 what? Centimeters. We are converting it to that. Then you'll be left with 4 centimeter here is to 1 multiplied by 100,000 is equals to 100,000. You can still use your calculator. It's okay. No one is going to judge you for using your calculator. It's 100,000 what? Centimeters. And now the second question that you must ask yourself, is it in its simplest form? No, we still have 1 is to 100,000. It means we can still simplify this further. So how do we simplify? We want to be left with 1 here. So we are going to divide by 4 centimeter. Divide this side by 4 centimeters. So the centimeter, they cancel. 4 and 4, they cancel. I'm left with 1 is to 100,000 divided by 4. I have my best friend that is going to assist me here. It is 100. And be very careful when you punch in, especially big numbers. Check the number of zeros. They have to be the same as in the question. It's 100,000 divided by 4, which is equals to 25,000. So our scale is 1 is to 25,000, which is the same as the previous example. So even if you decide to use 20 millimeters is to 500 meters, it must still give you the answer 1 is to 25,000. Even if you decide to use 40 millimeters and 1 kilometer, your final answer must still be 1 is to 25,000. So the most important thing here, it is the principle, the procedure, and the method that you are going to apply to turn your bar scale into a number scale. Remember, when you turn a bar scale into a number scale, first of all, your units must be the same. And then secondly, your scale must be in its simplest form. And that is how you turn a bar scale into a number scale. And then a quick activity on scales. Activity 1. If the length of the crop jet stream is 15 centimeters, guys, a jet stream is very big. So when you look at my ruler, 15 centimeters is from here to here. So an actual jet stream can never be 15 centimeters long. So what does this mean? It means that 15 centimeter, it is the distance on the map. So the examiner has already measured the distance on the map for you, meaning from here to there, it is 15 centimeters. So when you write your scale, I said the scale, it is always the map is to the actual. So this one that is measured, it is 15 centimeters. You write it here. Remember, we are not answering any questions. We are just collecting our information. So the length of the crop stream is 15 centimeters, while its actual length, so they've also determined the actual length for us. Its actual length is 25 meters. So here under actual, I'm going to write 25 meters. Determine the scale rounded off to the nearest 10 in the form 1 is to something. So we need to use these measurements to determine the scale that was used here. And then secondly, our scale has to be to the nearest 10, and it has to be in its simplest form. We are going to follow the same procedure that we followed with our examples. First of all, our main problem there is that our units are not the same. So now we need to convert our units to make them the same. And like I said, this side I have meters, and meters are bigger than the centimeters. So I'm going to use my King Henry to convert my meters to what? To centimeters. And then 15 centimeter is 2. How do we convert from meters to centimeters? We are converting from a larger unit to a smaller unit, so we are going to multiply. So it will be 25 meter. You multiply. If you use that conversion factor that we did, that is on the slide here, you will note that the conversion factor between meters and centimeters is 100. So I'm going to multiply by 100. And then we have 15 centimeters here is to 25 meter times 100. Remember, we are converting to centimeters here, ne? So let me say times 100 centimeters. So it is 25 multiplied by 100, which is equals to 2,500. So I have 15 is to 2,500 centimeters. Are my units the same now? Yes, and I'm happy. Is my scale in its simplest form? No. So I must still simplify it. I have 15 that is disturbing me. So how do I get rid of that 15 and make it a 1? I need to divide by 15 this side, and then divide by 15 on the other side. But it has to be 15 centimeters because we want the centimeters to cancel. So 15 and 15, they cancel. You have 1 is 2. 2,500 divided by 15. The answer is 166, 666. It's actually a recurring. So the scale is 1 is to 166,667. Is our scale in its simplest form? Yes. But did we follow all the instructions? They said our answer must be rounded off to the nearest 10. What does it mean to the nearest 10? It means our answer has to be in multiples of 10, the 166. So it can either be 160, 170, 180, 190, 200. It can be 166. It can be 175. So you ask yourself, from 166, is 166,6 nearer to 170, or is it nearer to 160? The answer is it is nearer to 170. So now when you write your scale, rounded off, it will be 1 is to 170. And 170 is correct because it's a multiple of 10. So now we followed all the instructions, and our scale in its simplest form is 1 is to 170. And this type of a question would normally be for 4 marks in the exams. All right, thank you. Let's move on to the next question. And then B, we have a plan of Beverly Hills High that is given below. We need to study the plan and use it to answer the questions that follow. So here is our plan. Let's quickly analyze the plan that is given to us. We have a plan. The first thing that I can notice there is that we are given a scale. The scale is 1 is to 500. We have the school hall, the science class, the toilets, the sports field, and the trees. That is the schoolyard of Beverly Hills High. Now, the instruction says, use the given scale, which is 1 is to 500, to calculate the real distance. Remember, what is the real distance? It is the actual distance, which is the length and the width of the sports field in meters. Now, most of the learners, this is where they get frustrated, that I'm only given a scale and I have to calculate the actual dimensions. Where do I even start? So now, this is where your usage of ruler comes in. It's very, very important. You're going to take your ruler. So I will just do the length. Your length is normally your longer side, and I'm going to take my ruler and use the millimeters and measure my length from 0 up to here. I'm getting 155 millimeters. The 155 millimeters is the distance that I measured on the paper. So it is 155 millimeter. It is measured on the paper. That is the distance on the map. What is my scale? The scale that is given is 1:500. Remember the scale, it is always the distance on the map is to the actual distance. So my distance on the map is 155 millimeters is to, I want my actual length. So when I want my actual length, how do I get my actual length? It's going to be 155 millimeter times 500. It will always be 155 millimeter. You multiply it by 500, and then you always divide by the value that is here. And in this case, we have a 1, so we'll divide by 1, which is equals to, I'm sorry, my slides are moving. So you have 155 multiplied by 500. We get 77,500. And then you divide it by 1, the answer would still be 77,500. But this is 77,500 what? Millimeters. What was the instruction? We need to give the actual dimensions in meters. So now we need to convert from your millimeter to meters. You are converting from your smaller unit to a larger unit. It means you are moving backwards. And when you move backwards, we are going to divide. What is the conversion factor between millimeters and meters? It is 1,000. So when you convert this to meters, it's going to be 77,500 divided by 1,000. So this divided by 1,000, please, the usage of calculator, 77,500 divided by 1,000. And the answer would be 77,5. 77,5 what? Meters. So that is the actual dimensions, that is the actual length of the sports field. Now you can use the same method, the same procedure to determine the actual width. I've measured the actual length. You're going to take your ruler and measure the actual width, and then use the same steps, the same method to determine the actual dimension, which is the actual width, and the answer has to be in meters. And then activity 2 on a school bag. Nikiwe is designing school bags for matric learners of Suncrest High. Below is the image of the school bag that she's designing. Measure the length of the school bag and calculate the actual length of the bag in centimeters. We can already see that we are given our bar scale, and our bar scale is in centimeters. So we need to calculate the actual length of the bag in centimeters. Now, when you work with a bar scale, the first thing that you do, you need to measure your bar scale and determine the dimensions on the bar scale. And my bar scale is already in centimeters. So I'm going to use my centimeters part to measure my bar scale. I am getting 14 centimeters from measuring here. So the measured distance on the paper, it is 14 centimeters, and it is equivalent to how much? I measured the entire bar. It is equivalent to 30 centimeters. And then now, I want the actual length of the school bag. So it means now, again, I must measure the length on the paper for this school bag. So this school bag, I'm going to use my centimeters again to save time. I'm going to measure using my centimeters. I'm getting 21 centimeters. That is the distance on the map. Remember, this is always your map distance. And I've measured what? 21 1 centimeters. And then I want what? I want the actual length. So how do I get my actual length? I will say AL, which stands for actual length, and it's 21 multiplied by 30. 21 multiplied by 30, and then you always divide by this one, and in this case we are dividing by what? By a 14. And then this is where our usage of calculator comes in again. This 21 multiplied by 30 to give us the answer, and then we divide it by what? By 14. So our answer would be 45, and it is 45, what? 45 centimeters, because all along we've been working with centimeters, so we don't need to do any conversions. Our answer is in centimeters. And for this type of a question, it is normally for 3 marks in the exams. And then the last activity, they say Nomsa lives in Northwest Province. She walks through the maize plantations every day when she goes to school and back. She came up with a diagram below to show her route from school and back. Before we can even look at the question, let's quickly look at the diagram. This is a diagram of Nomsa's plantation, the maize plantation, and this is Nomsa's house, and this is Nomsa's school. We can all see that we are also given a scale, and the type of scale that is used here is a bar scale. So let's go and check the question now. The question was saying, calculate the distance as the crow flies. Remember, as the crow flies, it means our distance on a straight line that she walks every day from home to school in kilometers. So now let us go and check our home. So we have our Nomsa's house, we have Nomsa's school. So I'm going to use this where the route ends or starts as my starting point, and then this line as well as my finishing point. So when you calculate the distance as the crow flies, you are assuming that Nomsa is traveling on a straight line from school to home. You don't consider that there's actually a route that she must follow. We will assume that she travels on a straight line from school to home. So when I measure with my ruler from here up to here, I'm getting 300 millimeters. So it will be 300 millimeters. And then from this point where I got my 3 millimeters to the house, okay, I'm sorry about that. Remember, it has to be on a straight line. And the 3 millimeters plus, I'm getting about 35 millimeters. So 300 plus 35 millimeters, which is equals to 335 millimeters. This is the measured distance from school to home. Now, what I need to do now, I must measure my bar scale. And when I measure my bar scale, because I use millimeters here, I'm also going to use millimeters to measure my bar scale. So when I measure my bar scale from 0 up to there, I'm getting 150 millimeters. So the measured distance on the bar is 150 millimeters. Is equivalent to how much? It is equivalent to 250 meters. And now my measured distance on the map that Nomsa will walk from school to home, it is 335 millimeters. Is 2, what are we looking for? We are looking for the actual distance. So to get our actual distance, we'll say the actual distance equals to, remember it is always this one, multiplied by that, 335 multiplied by 250. It is 335 millimeters, sorry for not writing the units, multiplied by 250 meters, and then divide by how much? By 150 millimeters. And the units, millimeter and millimeter, they will cancel. And then now let's use our calculators to say 335 multiply that by 250 equals to, we got our answer, and then remember to divide by 150. So your answer, it is going to be 558,33, but your answer is going to be what now in meters. But what was the instruction? The instruction was that we must calculate the actual distance in kilometers. So now remember our King Henry conversions, when you move from meters to kilometers, you are converting from a smaller unit to a larger unit. It means that you are going to divide. And what is the conversion factor between meters and kilometers? It is 1,000. That is correct. So you are going to divide by 1,000. So 558 divided by 1,000. Your answer would be 0.558 kilometers. You can round it to 2 decimal places to be 0.56 kilometers. That is our actual distance that Nomsa travels from home to school every day. Now, grade 12 learners, we have come to the end of our lesson. I hope we all enjoy this section of scale. Remember, if you can master this section of scale, then once we come into maps and plans, everything is going to be smooth when it comes to that section. So I really do hope that you've enjoyed this, you understand it, and you are going to practice it, because it's not going to help that you understand it and master it today, but then you don't practice it. You are going to forget it. So closing off, just a quick recap. We've worked with the different types of scales. We've explained the meaning of the given scale, be it a number scale or a bar scale. We've also discussed the advantages and the disadvantages of the different scales. We've used the given scale to determine the actual dimensions. And then lastly, we've converted a bar scale into a number scale. And then learners, just a tip on this section again. Take note that whenever the scale is given in the exams, number one, you will always, actually not always, but most of the time the examiner can ask you to identify the type of scale that is used. So you should know it's either a bar scale or a number scale, or the other person can say a ratio scale. And then secondly, you will be asked to explain the meaning of the scale. Remember, the way that you explain a number scale is not the same way that you would explain a bar scale. Thirdly, the usage of ruler. For this section, you need to have your ruler to the exam room all the time. Otherwise, you are going to struggle when it comes to answering this section. And then, again, when a scale is given, be it a bar or a number scale, expect to be asked to calculate the actual distance. And then lastly, your knowledge of convergence, learners. You've seen every single question. When we do the actual distance or the map distance, we need to apply our knowledge of convergence, and you are expected to know that by heart in grade 12. So this is the end of our scale section. Like I said, that I really do hope that you enjoy it, you understand it. And then learners, please, especially our grade 12 learners, remember, this is not a holiday. We need to use this time effectively, interact with your teachers and your peers on different social media. And then I know it's a very difficult period, but this too shall pass. Please stay at home and be safe. Thank you.